Quiero presentarles al primer expositor, Richard Soley. Yo conocí a Richard hace 20 años en un almuerzo en Sydney. Obviamente lo invité a venir a exponer a Costa Rica y desde entonces ha estado viniendo 2 o 4 veces al año. Richard es presidente y director ejecutivo del Object Management Group, la OMG, y también del Consorcio de Internet Industrial, Industrial Internet Consortium, el cual es administrado por la OMG y busca demostrar los beneficios de la Internet de las Cosas en aplicaciones industriales. Richard tiene un doctorado de MIT en computación y todos ustedes yo creo que lo conocen. Hoy nos va a hablar de la revolución industrial y la revolución de Internet. Richard.
Funciona, no? Sí. Okay. Bad news. Technical presentation I do in English. So I'm going to set the scene this morning for the presentations that come after, which will be much more interesting than my presentation. I'm going to tell you where this came from, this industrial internet idea, and how it relates to Internet of Things. And then I hope that this will be a good introduction for the rest of the day, which is focused on real uses of Internet of Things in industrial systems. But first, I want to give you some background. A very famous man said this 16 years ago. He was at the time the richest man in the world. You may remember he was very famous in the mid-90s for saying that he didn't need to do anything special to support the Internet. But in 1999, he wrote a letter to all of his employees in which he said, a fundamental new rule for business is that the Internet changes everything. Everybody agree? The Internet changes everything? Everybody's nodding? I don't agree with you. And I'm going to teach you not to answer my questions also. I'm going to give you some examples where the Internet has changed everything, and then I'm going to give you some examples where it hasn't. So we all know that the way that we read newspapers has changed, right? We read news online. In fact, in some cities, there is no paper newspaper anymore. People read their news online. Some of the newspaper companies may still exist, but only if they were smart enough to go online and make money online early on. So there's the change. This is the 4th one on the list. I know it's hard to see. People used to read paper newspapers. Now they read online. The way we listen to music has changed. We use computers to listen to music now. Sometimes those computers look like this, but this is a supercomputer of 25 years ago, right? And I have, I don't know, 10,000 hours worth of music on this. So the way we listen to music, we don't use boomboxes anymore. Some people I know, including myself, don't even buy compact discs anymore, let alone albums. For the people in the room that are maybe a little bit younger, I'll explain what an album is later. The way we watch movies has changed. My children, who are now 24 and 26 years old, they don't have television service at home. They don't watch television over the air. They don't watch television from cable. They only get things from the Internet. They watch what they want, when they want. The way we contact people has changed. How many of you use Skype? Anybody uses Skype? He doesn't use Skype. I use Skype. So yes, the Internet has changed a large part of the way that we operate, a large part of the way that we think about things. But I'm going to give you an example where it hasn't had a change. In 1980, I was working for a company. I was only 4 years old. So I was working for a company called Matakan that made something called a programmable controller. Anybody know what a programmable controller, also called PLC, is? We have a few people, yeah. So this is a device. It's actually a computer. But what it does is it controls a manufacturing line. Our customer was General Motors. Used to be a car company. They were very rich in 1980. We called them Generous Motors. This was the device that controlled their manufacturing line. The way that you program this device was something called a ladder diagram. In fact, there's a picture there next to the machine of a ladder diagram. If you wanted to get information from this computer into your enterprise resource planning system, in those days we called it the manufacturing resource planning system. You printed it out, you carried it over to the other computer, and you typed it back in. So here's the bad news. In 2015, the box is now made of plastic. The company has been bought 3 times. It's now a French company with a German name, mostly operating in the United States. It's called Schneider Automation. The way you program the device has not changed. It's the same ladder diagram. And the way you get information from this device to your enterprise resource planning, your SAP system, has not changed. 35 years. No impact of the internet. Nobody has thought, maybe we should connect this box to the internet so that we can connect these systems more easily. You still have to print information out and type it back into the other system. That's kind of crazy, don't you think? No, absolutely no change because of the internet. I'll give you another example. In 1950, the power networks of the world, the power grids, assumed there were a small number of power generators and tens of millions, maybe hundreds of millions of power users. No information flowed on the power network because you didn't need information. It was one way. Send power to the users. Here we are 65 years later, and those networks look exactly the same, even though we now have power generation all over the place with solar power, wind power, thermal power, and tidal power. So we could more intelligently move power around the network if we knew something about how power is being generated and when power is being generated. This is extremely important in some countries. For example, in northern Germany, some 40% of the energy comes from wind and from solar. And that's very lumpy, right? When it's very windy and very sunny, you get a lot of power. At night, you don't get much solar power, unless you shine a flashlight on the solar power. No, it doesn't work. So what does Germany do? When they have excess power, they sell it to Norway, which uses it to pump water up into dams. And then when they don't have enough power, they buy it back from Norway for twice as much. But we haven't changed the grids of the world. I'll give you one more example. Jet engines. Jet engines collect an enormous amount of information in flight. A modern jet engine today, when it lands after a long flight, will typically have up to 1 terabyte of data stored about performance metrics of everything inside the engine. So obviously you would think that the jet would connect to the Wi-Fi at the airport. Every airport has Wi-Fi. Upload the data to the jet engine manufacturer, whether it's Pratt & Whitney or Rolls-Royce or General Electric or CFM or Avic. The jet company would then compare that data to performance data going back for 20 years of that kind of jet on the wing of that kind of engine on the wing of that kind of jet, and then send a warning automatically to the maintenance base saying you should check something on this jet because it's having problems, the efficiency is lower, or maybe it's even going to fail. I'm here to tell you that's not what happens. What happens 55 years after the first instrumented jet engine is the maintenance person, if he has enough time, plugs a cable into the engine, downloads the data, and he probably doesn't have enough time because the jet is only on the ground for 25 minutes for one of the low-cost carriers. And maybe he looks at the data, if something doesn't look right, he might send it at the end of his shift to the jet engine manufacturer, and at the end of the week or end of the month, they might actually check to see if there was a problem with the engine. And then say, oh my God, where's N5216? We have to find it because it's about to fall out of the sky. No effect of the internet, no internet thinking. This is what I call it, thinking about the internet. And I could give you many more examples in oil and gas, and rail and other transportation areas, smart homes, and so on. That lack of internet thinking is pervasive in industrial systems. And I think that's going to change. In fact, that is already changing. This is a way to think about it from the point of view of an economist. In the late 19th century, we had a revolution called the Industrial Revolution. That was the move from human energy to machine energy, right? Steam and then internal combustion fueled by petroleum. In the late 20th century, we had another revolution called the Internet Revolution, moving human connectivity to connectivity on computers. And what I'm proposing is that we have to apply the Internet Revolution to the Industrial Revolution. And that's what I call the Industrial Internet. So this is why I call it Industrial Internet. Attendant with that were enormous increases in productivity. You can see this chart. Productivity increase of the Industrial Revolution was a factor of 10 or 20. The productivity increase of the Internet Revolution, something like 3 to 5. I don't know what the productivity increase will be for the Industrial Internet, but I know it will be large. And it will be disruptive. There will be enormous changes in our society, and we must prepare. So I'm not going to talk about this later, but I will say it's something we all need to think about. In a world of self-driving cars, for example, what is the job of a taxi driver? If I can call for a car anytime I want, and have that car delivered to me, and the car then takes me where I'm going, and then I forget about it, so I lease it for that short time. It's like a taxi, but it has no driver. What is the job of a taxi driver? I've taught you not to answer my questions. The job of a taxi driver in that case is to find another job. It doesn't sound polite, but it's a true case and we have to plan for it. Governments that don't plan for the disruptive changes will be in trouble. I will say that Internet of Things technology is also going to have impact on consumer technology. So you've already seen Fitbits. Some of you are probably wearing Fitbits or other kinds of watches that track your pulse and so forth. But imagine when that changes, when it notices that your pulse goes to 0 and then calls a doctor. That would be a handy thing, as long as you know that it's only going to your doctor. I actually have a friend who got off a flight in San Francisco. His Fitbit said that all of his numbers were wrong. He went directly to the hospital. He had just had a stroke, and they caught it early. So it's already saving lives. But it's not what I'm talking about. I'm talking about industrial systems today. So I'm also not talking about entertainment systems, and I'm not talking about automotive entertainment and Wi-Fi and so forth. I really am talking about power generation, distribution, and transmission, about jet engine performance metrics, and some of the other things we're going to see today. Why do we care? Well, it's a good size opportunity. General Electric did an analysis that was published 2 years ago by their chief economist, Marco Annunziato, that says that 47% of the world's GDP will be affected by the industrial internet. That's $32.3 trillion per year. That's a good sized market. Cisco says it will increase private sector profits by 21% by 2020. That's only 5 years from now. They call it the Internet of Everything. Gartner says it will be a $300 billion incremental increase in revenue by 2020 worldwide. McKinsey says $36 trillion of operating costs will be saved. I don't really care what you call it or whose analysis you guess is probably right, but this convergence of the Internet of Things, what the Germans call Industrie 4.0, what the US government and the Japanese government called cyber physical systems, I know that the opportunity is enormous. Where does that opportunity come from? First, new revenue opportunities. And you're going to hear some examples today. There will be revolutionary new products, and more importantly, revolutionary new services. Let me tell you about one. General Electric has always sold jet engines. You buy a jet engine, General Electric actually loses a little bit of money on every jet engine they sell. And then 5 times the cost of that jet engine is sold to the airline for spare parts over the next 20 to 30 years, the lifetime of the jet engine. They make money on the spare parts. They have a new way of selling jet engines, which is by hours of performance. They actually sell hundreds of thousands of pounds of propulsion for a certain number of hours and guarantee a certain use of fuel, of aviation gas. They're essentially leasing the engine. They're changing the model from a sales model to a lease model, from a capital expenditure to an operational expenditure. Even more interesting, General Electric has just started a new program in which they guarantee not only this year's fuel use, but they guarantee that the amount of fuel used will drop 1% per year for as long as the lease holds. Now, if you do that, it's General Electric that's responsible for maintenance. But General Electric thinks they can still make money, even though they are now taking on the maintenance cost and repair parts and spare parts for that jet engine, because they know much more about how the jet engine is being used, because they're tracking all of the performance metrics of the engine. And you'll see some more examples of this later today. Operational efficiencies mean better use of the workforce, means more productivity, and again, it means social disruption, something we can't forget. But it also means that we'll know that the manufacturer knows far more about the products that they're selling, or that they're leasing, and they can do a better job of maintaining them. Eventually, we'll be buying things that don't break. Or if they do break, we already know they're going to break, and we have the spare part in the mail at our front door. It's an enormous change. It's a disruptive change. These numbers are also from General Electric's report on impacts on the world economy. General Electric thinks that over the next 15 years, using Internet of Things technology in the industrial use of jet engines, they can save roughly $30 billion US. $2 billion a year. That's nothing compared to General Electric's, this is just General Electric's product, by the way. General Electric diesel-powered fleets, which power ships and so forth, $66 billion in saved fuel over the next 15 years. I like some of these statistics a lot. They think there will be 92 million internet-connected vehicles by next year. I don't know how that's going. And my favorite statistic is at the middle bottom of this picture. It has been proven that on average, police forces that equip every policeman with a camera, crime drops by 68%. I don't know if that's because the criminals don't want to be caught on the camera, or because the policemen, oh sorry. Improvements in healthcare. And this one interests me a lot, and we'll have a talk later about improvements in healthcare. GE thinks it's a $63 billion productivity increase, also a drop in liability. That's pretty important because it also will save lives. People die because a medical device is not being connected. But I'm not going to steal the thunder of one of our next speakers. So how do we get there? Obviously, we need to have connected industrial players, the manufacturers, the banks, the healthcare companies, and so forth, but also the IT vendors and the big data vendors and security systems vendors. I mean, after all, the information on your Fitbit, you may want to share it with your doctor, but you don't want to share it with every hacker in the world. The systems integrators need to be connected, the research organizations, the universities. We could hope that all of these organizations will simply talk to each other, but it might take decades. So what we propose is something that we call the Industrial Internet Consortium, or IIC, which brings together government players all over the world, connectivity companies, technology companies, standards organizations, open source organizations, industrial players, big data, and so forth, to work together to build test beds. What do I mean by test beds? Everyone says that one of the biggest problems in Internet of Things is the lack of standards. There are plenty of standards. That's the best thing about standards. There's so many to choose from. Thank you. What we ought to be doing is figuring out how to make these things work together. And if we need standards, develop standards. But first, try it. Prototypes, demonstration projects, pilots, whatever you want to call them. That's what the IIC does. We bring together all the different players, the users of the technology, the manufacturers of the technology, the researchers, the university professors, to try out these ideas together. What we expect is what we call transformational business outcomes. After all, that General Electric example of leasing jet engines is completely disruptive to General Electric's business. Why did they do it? Why did they disrupt their business? Because they knew that if they didn't disrupt it, somebody else would. That's an important point. It's hard to cannibalize your product line. It's harder to let someone else do it for you. So the purpose of the consortium is to accelerate the growth of industrial internet solutions by looking for these disruptive, transformational business outcomes. It was launched almost 13 months ago. by 5 founding members. I list them in alphabetical order. AT&T, Cisco, General Electric, IBM, and Intel. It's worth pointing out that 3 of these companies are technology vendors: Cisco, IBM, Intel. I know Intel is a dirty word here, sorry. But 2 of them are major users of this technology. AT&T and General Electric don't expect to be vendors of IoT solutions. They want to use IoT solutions. And that has continued to be true, that about half of our members are users of Internet of Things technology, and half of them are manufacturers of Internet of Things technology. Who are the members? Besides the 5 founding members, all of which are large companies, we have a large number of many other, about 80 other large companies, companies like Microsoft and Schneider Electric. Actually, I mentioned that's the one that makes programmable logic controllers, among other things. Hitachi and Tyco, companies all over the world. About 60% are headquartered in North America, 40% rest of world. The percentage of North American companies is still dropping. It's worth pointing out some of these are definitely never going to be IoT solutions vendors. In the upper left-hand corner, Codelco, that's the world's largest copper miner. They mine 1/3 of all copper in the world from one mine called Chuquicamata in northern Chile. It's quite amazing, actually. If that mine stops, the world copper price goes up. So they're not only makers of this technology, but users. We also have many, many, many small companies. About 90 companies are very small companies, because often you get new kinds of innovation from small companies that you would not get from large companies. They range, and I won't read these all to you, but they range from technology vendors like RTI on the left to, again, technology users like Wycon and Kepler. So we ensure that small companies can participate in this process as well. And we have many nonprofit, about 30 nonprofit and academic members. So those include standards organizations like the Open Group in the middle, and universities like Auburn University and Technische Universität Darmstadt and others around the world. Actually, Darmstadt was the first university to join the consortium. It's open to anyone. Any company can participate, and can participate in developing test beds. We have a process for developing test beds that starts with reference architecture. The reference architecture says what standards are there, what technologies are there that we can use to build a test bed in mining, or a test bed in manufacturing, or a test bed in smart energy grids. We then analyze the security requirements, and I have a little story that goes with that. I gave this talk in Berlin in February, and I was interrupted at this point by someone who said, "You are my worst nightmare." He said, "If you give me the level of security in my machines that is currently offered on the internet, I'm a dead man." So we have to solve the security issue, and that's very important to the consortium as well. With that information, reference architectures, security information, and use cases, we develop test beds. Let me tell you about 2 of the test beds that we have that we've made public. The first was led by Bosch and Tech Mahindra. Bosch, if you're not familiar with them, is a manufacturer of white goods, dishwashers, and laundry machines, and so forth. They also make all sorts of equipment for automotive systems, and they make manufacturing tools as well. Tech Mahindra, the other lead on this test bed, is one of the world's largest software systems integrators based in Bangalore, India. Bosch is based outside Stuttgart, Germany. And Cisco was involved as well. It was led by Bosch and Tech Mahindra. Very simple idea. They track everything on the factory floor: people, tools, parts, and inventory. That is, things that are being made by the factory. They use that information to make sure the tools are being used properly by people that have been trained to use the tool, and that the right part is being put into the right device, and that the right torque is used to tighten the bolts, and everything that has to do with running the factory floor to make sure that the parts are delivered just in time, and with very high quality of implementation. National Instruments is participating in this as well. And their focus is entirely on industrial manufacturing, where there has been no use of internet on the floor of manufacturing sites, factories, ever. The idea on the first phase of this project is to track especially hand tools. So the demonstration they did in Berlin in February, they actually had someone walk onto the stage and pick a bolt up and try to put it into a motor that was being built on the floor. The system then flashed onto his Google glasses. Sorry, that's the wrong bolt. Please put it back in bin 1 and take a bolt from bin 2. And then said, put it in this hole. Then says, wait, you haven't been trained to use this kind of drill. So it gave him training on his Google glasses instantly. And then he was allowed to use the drill. The drill automatically stopped when the right torque was reached for that bolt in that kind of hole on that kind of device. Then he tried to walk off the factory floor with the tool, and it said stop. The tool is not supposed to leave this area, well-defined area. Safety, security, training, all integrated. The current version of this testbed, which is now going into standardization and open source, locates devices and people on the factory floor within 1 meter. That's the technology that Cisco has available. They're now looking for technology to locate within 3 millimeters. So they know exactly which bolt is being put in exactly which hole. Unfortunately, the technology doesn't apparently exist yet. So they're looking for technology, and if you know how to locate inside a building within 3 millimeters, talk to me later. The second test bed that we announced is called Communication and Control. This one is run by National Instruments, Cisco, and RTI. RTI is a very small company based in the San Francisco area. And what they're doing is rebuilding the power networks, the power grids of San Antonio, Texas. What they'd like to do is integrate solar and wind. There's plenty of solar power and plenty of wind power in the San Antonio, Texas area. This is South Texas. Right now, that's very hard to do because the grid was designed almost 100 years ago and has not changed in design in that time. They have no way of controlling what to do with excess power, how to automatically bring in power from other networks when necessary. And if you're using wind power and solar power, that's absolutely critical. And the technology that they're putting in place is something called microgrids. So they're power grids at the level of a neighborhood, and then an intelligent system for buying and selling power across the different neighborhoods as necessary. On the first phase, they will be running a demonstration system outside of San Antonio. And the second phase, they will actually build it with Duke Energy, which is the main power supplier in the San Antonio area, in San Antonio, and eventually in phase 3, replace the power network of San Antonio. So this is a major project. First simulation, is being done in Southern California. They expect this test to be live within a couple of years, and the people of San Antonio are actually depending on power from these grids. What's driving it now? Why are we talking about Internet of Things now, besides the fact, of course, that Gartner says it's very exciting? I think the most important thing is low-cost technology. Sensors and devices, actuators have dropped in price to near zero. All of the systems you're going to see today are based on sensors that literally cost almost nothing. But also processing power has dropped in price to near zero, and connectivity has dropped in price to near zero, where you don't have a monopoly of connectivity suppliers anyway. Most of the presentations about the Internet of Things start with Cisco's number that says that there'll be 70 billion connected devices by 2020. I don't care. That's not interesting. What's interesting is how will we use them, how will we connect them intelligently, and how will we protect privacy in that world. Also, the price of big data, of managing large amounts of data and unstructured data, has dropped precipitously over the last 10 years, especially because of Google's Hadoop project. And smarter machines are everywhere. I see this in 3 phases. Smart manufacturing, which is already starting to happen. Smart products, which are starting to happen. Products that have intelligent information internally and talk back to the manufacturer. And eventually, smart data. When your manufacturers know more about how their products are being used, they can do a better job of matching the requirements of the consumer to the devices they ship. Some of you have heard me speak before. I usually talk about standards. I only have one slide about standards here, and only to make it very clear that the IIC is not a standards organization. We don't develop standards. We run test beds to make sure that we understand how to use this technology. We do think standards will be necessary, however, so we've developed liaisons with standards organizations to deliver to them requirements and priorities for standards based on what we learn from the testbed projects. No big surprise, OMG was willing to create a liaison immediately. I signed both sides of the agreement. Also we have strong relationships now with standards organizations like GS1 and OASIS and the Open Group and SGIP and with open source organizations like UPnP, Open Interconnect, and Eclipse Foundation. And this is already working. So the results of the first phase of the Bosch Tech Mahindra project are going into open source at Eclipse and into standardization at OMG. We've learned a lot from these test beds, so we can make that into standards that make sure that we get interoperability between devices. It doesn't make sense to develop standards when you don't know what standards you need. We only have 2 test beds that we're talking about publicly. There are 4 other test beds that are currently operating, but not announced yet, so I can't tell you, but they're in things like healthcare device integration, in smart cities and smart counties and smart countries. We also have 12 other testbed projects that are currently under development, and by the end of the year we should have about 12 testbeds operating. So what does the future look like? The future looks like jet engines that are automatically maintained far better than they are today. Not just so that the jet continues to work. Jet engines already work really well, but so that they can be more efficient. If the maintenance people at an airport know that the 3rd rotor on the 2nd compressor stage should be replaced to get another 1% of efficiency, they'll know it immediately and they can make that change immediately. If we know the factory is going to have downtime because we know a part is going to break, we can get that part to the factory earlier. If we know that 2 cars are going to collide because they're talking to each other, we can make sure that they don't collide. I'll leave the last one on the right there. That's an oxygen sensor. It senses the amount of oxygen in your blood. They don't work very well. But if we know more about the medical devices attached to your body, we can do a better job of saving patients. And of course, saving insurance liability too, which is important for someone. But one of our speakers later today is going to be talking about that. What I want to get across to you is that things are coming together. Things are starting to work. We have testbed results now, even after only about a year. The organization continues to grow. Last week, I was at Hanover Fair in Germany. No, this week. Sometime recently, I was at Hanover Fair in Germany. We now know that one of the largest elevator companies in the world is joining. Another major manufacturer of tools is joining. Everyone is looking at this technology and how to make their systems more efficient, work together better. So the opportunities are there. And you're going to see some examples today in spaces that you probably haven't thought about. Agricultural systems, healthcare systems, cows. And I hope that you enjoy it. Thanks very much. That's how you reach me. But you have a copy of this in your slides. You don't have to write it down. We're going to take questions at the panel also. Thank you.
Muchas gracias, Richard.